Okay, so all right, so I'm in VS Code to start off here. I'm already connected to a Python environment, and this Python environment has NumPy installed. Again, since this is now an extension or a module or a package, you can't just use it in base Python. It has to be installed into your environment. And then to actually use it, we got to do our import, right? So here I'm doing import NumPy, and again, that'll allow me to use the classes and the methods and the functions and whatnot made available by NumPy. And then I'm giving it the alias of np with the as keyword. And that's kind of the standard for NumPy. You don't have to do that, but that's generally how people read it in. It just can make your code a little bit more concise. You don't have to type NumPy all the time. So anyway, if you run this and you get some type of error that says like it's not found, then that means it's something's wrong with the environment, or Python is not installed in that environment or whatnot. But if it runs, then that means you should have access to NumPy. Okay, so in this first block of code, I'm just making a list, and then I'm converting it into a NumPy array. So remember, lists can be mixes of like strings and numbers and booleans, or all one type of data. Here I've just got a bunch of numbers, and again, the square brackets indicate that it's going to be a list. And then to convert that list into a NumPy array, I just use the array function from NumPy, so np.array, and I just feed it the list. And then here I'm just printing back the types, and then I print the content. So if we run this, we can see that the list object is a list, right, of class list. And then once we've done this conversion, it is of type numpy.ndArray. So effectively, this is a new class or a new type of data that we can work with. They're basically storing the same information in both cases, right? But it's a little bit different in terms of how you can work with it. And also, how it's like stored memory and whatnot. So anyway, that's just converting a single list into a NumPy array and then just introducing that data type there. Okay, again, one of the power of NumPy is that you cannot just you can have more than just like a series of values. So generally, the term that we use if we have a single number, like a single value, like an array that stores one number, we would call that a scalar. And if it's a series of values, like what we just did, like a series of numbers in one dimension, we would call that a vector. And then that can be extended into multiple dimensions. So, for example, you can have a matrix of values where you have rows and columns. Think of like cells in an Excel spreadsheet where the rows are, like 1 through 10, and the columns are like A through F or something, right? So that is generally known as a matrix, a two-dimensional array. And then you can have 3-dimensional arrays, 4-dimensional arrays, 5-dimensional arrays. So that's kind of that's the power. One of the big powers of NumPy is you can store numbers in different dimensions, and they can even be reshaped and whatnot. For example, if you had an image like red, green, blue, true color image, you could have a channels dimension and a height and a width dimension. Okay, so what I'm doing here, let me just show you this, is I'm making a two-dimensional array or a matrix, right? And you can see that I've got basically two sets here of brackets. So excuse me, the first row of values is basically the first row here in the array, and then the second's the second, the third's the third. So we basically have rows and columns, right? So if I wanted to define grab one of these values, I'd have to say its row is column, or its position in dimension 1 and its position in dimension 2, right? So that's a two-dimensional array, and I created that by feeding in an array of arrays. So you can see that basically this is its own array. So there's 3 arrays there, and then they're all within one array. So arrays within an array. This one's a little more complex, so now the goal is to have 3 dimensions. So you can see there's a set of 3 brackets here. Excuse me. So we have an array object, it closes here. And then this is an array that holds 3 arrays. And then another array that holds 3 arrays. And then another array that holds 3 arrays. Oh, I'm sorry, I'm using the term wrong. Lists, right? So this is 3 lists. So it's lists within a list within a list, right? So if we run this, then we get back this. And this would be similar to something, again, like an image, right? Where we have rows and columns that define like the height and width of the image, or like the number of pixels and the height and width dimensions. And then we have the 3 separate layers or bands or channels, right? That represent like red, green, and blue, right? Okay, so in summary, real quick, again, we can take a list, convert it into a NumPy array. If it's a single value, we generally call it a scalar. If it's one dimension, like a series of values, so we generally call that a vector. 2-dimensional arrays like this, we generally call matrices. And then we can have 3D, 4D, 5D arrays, right? And here I'm just constructing those from, lists of lists or lists of lists of lists or whatever. Okay, NumPy does provide some methods for generating arrays and filling them with values. Okay, so for example, a range and line space are a couple of different ways that you can do that. So if we hover over this, we can see the docstring there. So it says returns evenly spaced values within a given interval. Values are generated within the half open interval, start stop. In other words, interval including start but excluding stop, which again is like Python's kind of standard. So let's just so anyway, that's a range. Line space here returns evenly spaced numbers over a specified interval. It should tell us the arguments. I guess that's not there. Ones generates an array of ones. Zeros introduces an array filled with zeros. Rand is used to generate random values. And then rand int is used to generate random integers. So let's just create all these and then have a look at the content. Okay, cool. So here's our first one. So with a range, basically what you specify is a start and a stop, and then a spacing, right? So we are going from 0 to 100, but remember 100 isn't included. And we're going to go to we're going to do steps of 5. So 0, 5, 10, 15, 20. And then just when you get to the end, it ends on 95 because 100 is not included. So that doesn't actually, it can't include it. So for example, I wanted to have it included, I could do something like 1 or 101, and then it'll go out there to 100 now, right? Okay, line space, these are, again, sometimes confused. The difference here is that instead of defining a step size, you specify the number of values that you want. So here we're basically saying 5 evenly spaced values between 0 and 100. And you can now give us 0, 25, 50, 75, and 100. So step size for line space, step size for a range, versus number of evenly spaced values for line space. Okay, so and then ones here, what I did was I created arrays filled with 1 and of a certain dimensions, right? So basically I have the first dimension is 3, and then 4 and 4. So again, so there's basically 3. You could think of these as channels or whatnot, and then 4 by 4 rows and columns. Note the dot basically means that this number is being treated as a decimal value or a float, as opposed to as an integer value. And we'll talk about data types later on. Okay, cool. And then the rest of these are just random stuff. So here we have Zeros, same thing. I'm just filling it with zeros there. Now instead of doing 344, I did 342. So they cut it off, but there's basically three like channels and 4 rows, 2 columns. And then again, random can give you random values between a start and end and a certain number of values. And then random integer actually gives you random integers between values and a defined number of values. Okay, so that's just some examples of data generation using NumPy.